Machine learning is a subset of artificial intelligence in which a system learns from data, identifying patterns and improving its performance with experience, rather than being explicitly programmed for every situation. The cleanest way to hold the idea is to contrast where the rules come from. In conventional programming, and in the expert systems of the last lesson, a human writes the rules and the computer applies them. In machine learning, the human supplies examples and the computer works out the rules for itself. That is the inversion, and everything else follows from it, which is also why machine learning is not simply better than an expert system. It is the right tool for a different situation, one where a human could not write the rules down even if they wanted to. Set the two side by side. An expert system is rule-based. Humans manually write every if-then rule, exactly as we watched in the last lesson, and it is static. It knows only what it was told and cannot handle a situation nobody programmed into it. Machine learning is data-driven. The computer analyzes many examples and derives its own rules. And it is dynamic. The more data it sees, the more accurate it becomes. But the expert system has a real advantage that is easy to overlook, and it is worth stating because balanced answers score better. Because its rules were written by people, you can read them and you can ask why it reached a conclusion. The chain of rules is inspectable. A machine learning system frequently cannot explain itself. It produces an answer, and the reasoning is buried in millions of numerical weights that no one can read. So the trade is flexibility for transparency. That matters enormously when the decision is a medical diagnosis or a loan refusal. So when is machine learning the right choice? 3 situations, all of them cases where writing rules is impossible rather than merely tedious. Unstructured data. Recognizing a face or a voice involves billions of tiny variations, and no human could write enough if statements to cover every angle, every lighting condition, every accent. Constant change. Spam email changes every day, so an expert system would need a person continually rewriting its rules, whereas machine learning adapts from new examples and hidden patterns, connections in enormous datasets, DNA, financial markets, medical scans that are invisible to the human eye, so nobody could write the rule because nobody knows the rule exists. Notice the common thread. Machine learning is not for problems that are hard to compute. It is for problems that are hard to specify. Let me train one, because learning is a change over time, and a description in the past tense cannot show it. A spam filter. It starts knowing nothing at all. No rules about spam, because nobody wrote any. It is given a training set, a large collection of emails, each labeled by a human as spam or not spam. Those labels are the crucial ingredient, and this is called supervised learning, because a human supervised the examples. The algorithm analyzes them and finds patterns statistically. Certain words, phrases, and formatting appear far more often in the spam pile than in the other. It builds a model from those patterns. Now test it. A new email arrives offering a free prize, and the model classifies it as spam correctly because those features were common in the spam examples. But now a second email arrives, a genuine message from a colleague using the word free about a free trial at work. The model gets it wrong and marks it as spam. The user corrects it, clicking not spam, and that correction becomes a new labeled example. The model updates. The word free alone is now weighted less heavily because it has seen a counterexample. Send a similar email again and it is classified correctly. That is the whole mechanism. And notice that nobody wrote a rule at any point. Now hold on to something the scene makes visible. The system learned only what was in the examples. It has no idea what spam is or what free means. It learned that certain patterns correlated with a label a human applied, which is exactly why bias in the training data becomes bias in the system. If the examples are skewed, the patterns it finds are skewed, and it will apply them confidently. The general process, which applies far beyond spam. Collect data, a large quantity of relevant examples, and quantity genuinely matters because patterns are statistical. Label it if you are doing supervised learning. A human marks what each example actually is. Train. The algorithm processes the examples and builds a model of the patterns it finds. Test. The model is run on data it has never seen, which is essential because a model can appear perfect on the data it was trained on and be useless on anything else. Then deploy it and continue to improve it as new data and corrections arrive. That testing step is the one students omit, and it is worth understanding why it exists. Testing a model on its own training data tells you it memorized the examples, not that it learned anything general, which is a different claim entirely. Applications briefly, since the pattern is by now familiar: image and facial recognition, speech recognition and translation, recommendation systems, fraud detection, medical image analysis, self-driving cars, weather forecasting. All problems where the rules could not be written by hand, and the limitations which questions do ask for. It needs very large amounts of data, which not every problem has. It can be confidently wrong, giving no indication that it is operating outside anything it has seen. It generally cannot explain its reasoning. It is computationally expensive to train, and it inherits any bias in its training data, the most important limitation, because the system will apply that bias consistently at scale and with an appearance of neutrality that a human decision would not have. Remember that all of these are narrow AI. A model trained to recognize faces cannot be asked to detect fraud and has no idea what a face is. 4 things to take into the exam. First, define machine learning as a subset of AI in which a system learns from data and improves with experience, rather than being explicitly programmed. The phrase "rather than being explicitly programmed" is usually where the mark is. Second, the difference from an expert system is where the rules come from. Humans write them in an expert system. The computer derives them from data in machine learning. Say that rather than saying machine learning is more advanced. Third, describe training as a process with named stages. Collect data, label it, train, test on unseen data, deploy and improve. And fourth, when giving a limitation, name the mechanism. Bias in the training data produces bias in the model because the system learns only the patterns the examples contained. That last clause is what shows you understand why, and not merely that.